C3. Transforming graphs of functions, example 13. The graph of y equals cos 2x, take away 1. First of all, I'd like to point out that this is different to y equals cos brackets 2x minus 1. If we had brackets around the 2x minus 1, this would be a completely different graph. Because we don't have brackets, that's telling me that the angle is 2x, and then we've got a big minus 1 at the end. So there's two transformations here, one coming from the 2 and another one from the minus 1 at the end. Let's think about the original cos x graph. What would it look like? We need to know the cos x graph starts at 0, 1, goes to the x-axis at 90, we get a minimum at 180, back through at 270, maximum at 260, and it's got symmetry in the y-axis, so that's how the cos x graph would look. I've chosen to do this question in degrees, even though it didn't specify whether we were to use degrees or radians. Don't worry, in an exam, they would tell you what angle they wanted to use. So the cos x graph looks like that. The 2 with the x, think about what transformation that would achieve. Because it's with the x, and by that I mean we don't have 2 cos x, instead we've got cos of 2x, so the 2 goes with the x, we're going to get a translation in the x direction. It's going to be a stretch scale factor of 1/2, which is the same as a squash scale factor 2. So it's still going to go through the y-axis at 1, but instead of going through the x-axis at 45, it's now going to go through 22.5. So the first minimum is going to be when x is 90. Now before the squash, the cos x graph has a period of 360 degrees. That means it does one complete wave every 360 degrees. Now we can see the period is 180 degrees, it's been halved. So it's going to achieve another complete wave in the next 180 degrees. And we'll still have that symmetry in the y-axis. So there we go. The period of the graph is now 180 degrees because of the squash, scale factor 2 in the x direction. The minus 1 at the end will bring the whole graph down by 1. So these maximums at the moment have a y value of 1, and the minimums, although I've not lined them up perfectly, have a y value of -1. So with the -1 at the end, they're going to move down. So I'm going to try and do this section by section. So that's going to go down 1 unit. So is this section and that section as well. So now the maximum points in the graph have a y value of 0, and the minimums have a y value of -2. And that's the graph of cos 2x, take 1 in degrees.